Welcome to the session 39 of LMS. Program is for BSc Mathematics, semester 5th semester, and title of the paper is Numerical Analysis. So, in that we are going to see the topic finite difference, in which in this session we are going to solve some of the problems. So, first we will go for the recap. We have understood the concept of nth difference of a polynomial of nth degree is a constant, and if we go for a n plus 1th and higher differences of nth degree polynomial are zeros. So at the end of this session we can able to solve the problems related to nth differences, shift operator E, and forward difference. So we'll see some of the problems. So first example is like this. Solve this delta square divided by E into x cube. So I have taken that. So E means we know that. Delta means what? It is E minus 1. We applied it here. So now I will expand this E minus 1 whole square by A minus B whole square formula. We have expanded it. Now I will split this denominator E to each and every terms of denominator to numerator. So E square will become E, 2E will become 2, and 1 divided by E. Now I will multiply this x to each and every term of this bracket terms. So we will get this. Now I will apply the E into f of x formula. What is the E into f of x formula? We know that E into f of x is equals to f of x plus h. So we will apply this formula, right? Now we will apply this formula to each and wherever E is there we applied here. Okay, so here we applied it, here we applied it. So we have got x plus h whole cube. Here x plus h whole cube is there. So if you simplify all the terms here, so I will get this answer, right? Okay. Now we will see the next problem. Now second problem is like this. Show that forward difference minus backward difference is equals to forward difference into backward difference. We have delta of f of x is equals to f of x plus h minus f of x. And what is backward difference formula? F of x minus f of x minus h, right? So I have taken this forward difference into backward difference of a function, right? I will keep this forward difference as it is here. I will apply the backward difference formula here. We know that. We are defined it here. Okay? That is the formula. We know that. Okay? So now we have done here. F of x minus f of x minus h. Right? So now I will apply this forward to each and every term of the bracket terms. Delta of f of x, I will multiply this delta. So I will remove the bracket, that means, okay. So we have applied it. Now what is delta of f of x? We know that f of x plus h minus f of x. Similarly for this one, f of x minus h plus h. Plus h minus will get cancelled. So f of x minus f of x minus h as it is. Now what is this? This is forward difference of f of x. What is this? This, if you see, this is nothing but an here. That is backward difference of f of x. Right? Now I can also remove f of x. So hence my result is here. Right? Next one. Evaluate this term. Whatever it is there. Right? That is backward difference plus forward difference whole square into x square plus x plus 1. Okay, and he has given that interval of difference is 1, that is h value is 1 he has given. Okay, right. So I have taken that problem. Backward plus forward whole square is equals to. So what I can say? This is, I know that. What do you mean by a backward difference? It is nothing but an delta into e power minus 1. This is one of the relation. We have derived it. Okay. So delta into e power minus 1 plus delta as it is whole square. Now what I will do it? So in this term, I can take common as a delta. We have taken delta as a common. So remaining thing I have wrote it as it is. Right. So what do you mean by delta? Delta is nothing but an e minus 1. We know that relation. Here it is. Right. So e minus 1. And I kept this bracket as it is. Now if you simplify this, I will get e minus e to the power of minus 1 whole square. Now apply this a minus b whole square formula. You will get this. Okay. Now I will consider that problem. So what is that problem? Backward difference plus forward difference whole square into function f of x, that is x square plus x plus 1. So what is this backward difference plus forward difference whole square? It is here. Okay, I'll substitute that here. The function will be as it is. Now if you apply this e to every term, this e to each and every term, what will be the e square of x square, right? E square of x square means, so e square of x square it is. So what happens? It is nothing but an x plus 2 whole square. Where is x? X is there, x should be replaced by 2 here. Okay, like that. If you apply the definition of e power n times of f of x, we will get this. Here h is 1, we know that. Okay, we have got this one, these terms. Right. Now if you simplify that, I will get it here as 8. Fine. Right. Next problem we will take it. So find the value of delta to the power 6 of y naught in the given data. So here is the data they have given. So we know that. What is that? Delta is equals to e minus 1. This is one of the relation between delta id. Now I have to find delta to the power of 6. So I will take delta to the power of 6 into e minus 1 whole to the power of 6. Now I will expand this by binomial theorem. Okay, here it is there up to the 6c6. Now I will write this e power 6 as it is. 6c1 means I know that e6, 6c2 means 15, right? This is. So like this, if you expand each and every term, 6c2, 6c4, we are going to get it as 15, and it is 6 plus 6c6 is 1. Okay. Now what I will do, it means now apply delta to the power of y of 0. Here you can see I have taken y of 0. So if for each and every term of this one also I have to write, I should multiply with y of 0, right? I have taken it. Now multiply that. Now what I will do it? Now you can see it here. What is this e power n of y of x? It is nothing but an y of x plus nh. So I have taken that definition. I have wrote that. Okay. So you can see e power n is 6. So why not? It will become y of 0 plus 6h. So you can see here. We can see here. Right? We have wrote it here. Similarly, all the terms, for each and every term I applied the e to the power of n of f of x can be written as f of x plus nh formula. So we will get this one. Now here we will say h is equals to 1. Right? If h is equals to 1, what happens here? H is equals to 1 means it will become y of 6. It will become y of 5. So I wrote all the terms here. Now if you substitute the values of if you substitute the values of y of 6. What is the y of 6 value? Y of 6 value is 10. Right? So here there should be no e at all. So some mistakes in. So this e is not there. Okay. After substitution. After substitution, that e should not be there. This also e is not there. Okay. This e is not there. After substitution of e, we have to remove that e. Typing mistakes. So now you can see delta to the 6 of y naught. I will substitute each and every value. Y of 6, that is y value when x is equals to 6. You can see y value when x is equals to 6. Here it is. Here it is. X value is 6. Then what will be the y value? It is 10. Like that we will substitute all the values over here for each and every term. Y of 5 means 16. Y of 4 means 32. Y of 3 means 75. Y of 2 means 21. Y of 1 means 8. Y of 0 means 4. If you simplify this, then I will get this answer. This is our solution. Right? And now next. Another one problem. So they are given the U0, U1, U2 and U4. And we have to find U of 3 here. Now here you can see it. What do you mean by U of 0? It is nothing but an U of 0. That is U value when x is equals to 0. Okay. So at the same time, how many values are given? 1, 2, 3, 4 terms has been given. So we can say that we will assume that u of x is a polynomial of degree 3. That is 4 minus 1. So fourth difference will be 0, we can say, right? So fourth difference is 0. Therefore, fourth forward difference will be 0. I have taken it, right? So delta to the power of u of 0 I will consider it. So what is this delta? Delta means e minus 1. I have applied it. Again I will apply the binomial theorem. So I will get these terms, right? So what happens? E power, I will apply this u of 0 to each and every term of this one. So I have applied it. You can see it here. We have got like this. Okay, now e power n of f of x. This is term is. What is it? E power n of f of x. It is nothing but an f of x plus nh. Similarly, we can write u of 0 plus 4h. 4 into u of 0 plus 3h. 6 into u of 0 plus 2h. Right? 0 plus h and u of 0 as it is here. Now we will take it here, h is equals to 1. So if h is equals to 1, if you substitute all this here, what we are going to get? U of 4 minus u of 0. 4 times of u of 3. 6 times of u of 2. So similarly, we can get this term, u of 1 and u of zeros. Now what do you mean? As I told you, it is nothing but u suffix 4 I can write it. Right? I wrote all the values here. You can see it here. I wrote all the values of suffix value. So now I will substitute. What do you mean by u of 4? In the starting he has given. What is the u of 4 value? It is, you can see it here. U of 4 is 374. So I will substitute that value. Right? U of 3 I have to find it. So I have not substituted it. I have not substituted it. U2 value I have substituted it. U1 value I have substituted and U0 value. If you simplify this, I'll get my answer. That is U of 3 is equals to 300. Right? So some of the books for the references here. So by G.K. Ranganathan, by Swami, by Prabhakar. So some of the books are there for reference. And thank you, friends.